Hello everyone, in this video I will demonstrate how to create a custom dataset for object detection task. We will be using yolov5 model to train our object detection model. So to get started, I have collected few images of the equipments in our lab. So I want to train a model that can identify screwdriver in the image. So for training the model, we need to feed the model with the data of the image, and also we need to point out where the screwdriver is in the image so the model can learn the structure of the screwdriver. So this task is also called data annotation. So at first I have collected few images, and the size of these images is quite big. So let's bring it down so that we can train a little bit faster. So you can resize it any way you want, I mean by any tools you want. I will be using this Python script to resize the image to size 416. So basically it will not be 416 into 416, but it will maintain the aspect ratio. So the longest width or the height will be 416, and another one will be adjusted accordingly to maintain the aspect ratio. So let me just resize these images. Desktop. Python resize the If you want to use other tools to resize the image, then it's also fine. Okay, now I have resized the images. Let me just get all the resized images into one folder. Select all the resized images and paste it in resized. Okay, now we have all the images resized. Let's see in the properties. Okay, now the image is of width 416 pixel. Now we can use different tools to annotate the data. I will just mention two of these tools. You can see how we can annotate the data. First tool you can use is makesense.ai. makesense.ai. The reason I want to show this website is because you can use it right out of the box. You don't need to sign up or log in. So we can just get started and drop our images. Let's say I'll just drop one image for now, and our task is object detection. So go to object detection, and at first we can create labels. So to create a label, so label basically means what were the objects that we want to identify from the image. So we just want to train a model that can identify screwdriver. So I will insert a label screwdriver and start a project. So to start with, now I have to select a region around the screwdriver so that the model will learn the structure of the screwdriver. So I can select from here until here. So make sure you will not cut the edges of the screwdriver, and also make sure you will not go very far from the actual object. So you just want the model to learn the actual structure of the screwdriver. And then after we created the bounding box around the object, we can select the label here, select screwdriver. So you can also add all the images, or you can add all the images at first and work with it. After you have selected all the labels, we can export our annotation. So since I have only one image here, let's see how we can export annotation. So since we are using YOLO format, YOLO model to train our object detection model, so you just select YOLO format and export. Okay, exported. Let's see what the file looks like. Okay, now you can see it will export a zip file in which there is a txt file with the same name as the name of the image. And let's go through the information inside the txt file. So it basically has 5 things in this txt. So one row is for one object. So if we had 2 bounding box in our image, then it would have 2 rows of data. So the first item here, 0, means the label. So since we have only screwdriver as the label, so it will have the default value 0. If we add something more, so it will be continuous, 0, 1, 2, 3, 4. We will have a separate file to map the label with this number. So what this says is, okay, this is the screwdriver, and the first 2 items after the label are the center point of the bounding box. So when we create the bounding box, it will save the center point of the bounding box, and the last 2 are the width of the bounding box and the height of the bounding box. So this is the data that we get when we save in YOLO format. Okay, so we went through this makesense.ai tool. So another tool I want to introduce to you is cvat.org. cvat.org. So this tool is also a free and open source tool, but to use this you have to create an account and sign up. So after you sign up, you will see your account and then go to tasks and create a new task. So give the name to the task, screwdriver test. Project is optional, so we can also add our label here. So our label is screwdriver, so only screwdriver, so screwdriver is added. Now we can click and drag the files here or directly open files here. Okay, I will go to resized. I will use all the resized files and open. So after that I will submit. So data is being uploaded to the server. After it is uploaded, you will see the task has been created around here. So we will open the task. Okay, now you can see the task that we just created, the task for annotation. So let's go to the job here for the annotation task. Okay, from this window we can select the rectangle, draw a new rectangle, drawing method 2 points, and shape. So similar to the previous tool, we can select the object. So you can see it created a bounding box with label screwdriver. We can go to the next image. So for the next image you can again click the shape, or you can press N and for new, and then create. Next, you can see this object has this image has 2 objects. So we will create 2 bounding box for each object. Next, new. Next, make sure the bounding box encloses the object completely, and also don't go too far from the object. This seems little of this. Okay, next. Okay, I finished annotating all the images that I had, so I can save it. So after saving, I can export directly from here, or I can go to tasks, and in the tasks I can see the tasks that we created, and go to actions and export as dataset to export whole dataset. Or if we just want the annotation values, we can just dump annotations. So let's try dump annotations, and there are many format that we can download our dataset into, but since we are using YOLO, we will download in YOLO format. Go to dump annotation and YOLO format. So it will create a new zip file. So if you go to the zip file, you can see there is the annotation file for each image. For the image that has 2 objects, so you can see there are 2 rows of data, since this image had 2 objects. So apart from data annotation, we also have one optional step called data augmentation. So in some cases, the data that we have, the images that we have, might not be enough to train a good model. That means our model might not have that much accuracy because of lack of data. So we can use the process called data augmentation to create some synthetic data. So for creating the synthetic data, there are also many tools, but the tool that I like most is Roboflow.com. But you have to be careful that this is not free. I mean, it is free for certain limit only, so it is not free for maximum usage, but we can use the starter pack here. So you can start the Roboflow if you want to do the data annotation part. The data annotation part is for data augmentation part. Data augmentation part is optional. This you can try to make your dataset more rich. So you can try it now and sign up, register. So I already have the account. I will just sign in. And let me go here. I will download my image for annotation as Pascal VOC. Okay. So I downloaded as Pascal VOC. Let me extract that. New folder, Pascal VOC. So this is the dataset in Pascal VOC format. I just downloaded this in this format to upload in Roboflow. We can also upload the data in YOLO format, but if we upload in Pascal VOC format, it will take the name of the labels automatically, so we don't need to add extra files. So from here, create a new dataset and give the name to the dataset. Screwdriver test and annotation group. This annotation group is the type of subjects that you are detecting, so you can put the name that is relevant. So for this one, let's put equipments, equipments, and create a dataset. So now I have to add images and annotations. So the supported images are JPG, PNG or BMP, so I can upload the images that I resized. And for annotation format, it only supports JSON, XML, CSV or TXT. So let me select the files. Okay, from resized I will select all the images. Open. So these images are here. And for annotation, from Pascal VOC, just annotation, I will select all the annotations. So now you can see it has loaded the image files and the annotations too. So now you can see there is bounding box around the object. So after this we can finish upload. So after this it will show a dialog whether we want to split these images to training set and test set or not. So this is again up to you. If you want to create a train test set programmatically, that is also okay, or you can let Roboflow do that task for us. Okay, let's say add images, all images to training set, or we can say you can split the data between train, valid and test. Let's say we will use 80% train and 20% valid without test set. So continue. Okay, now for the augmentation, right now let's see the size of the data set is 9 images only, and I will add augmentation step. So what does the augmentation do is it will try to change the image a little bit or by however augmentation that we want, and it will also automatically add the bounding box to that image based on the original images. Let's say if we select flip, so that what it does is it will flip all the images and keep in the data set. So it will look like a new image for our model to train on. Okay, flip, after pre-process it will look like this. Apply, and we can also add other, okay, rotation and apply. Let's say crop, apply, shear, apply. So you can add more augmentations. So now you can see our original data set was 9, but after augmentation there will be total of 23 images. So let's generate it and let's give a version to this dataset. Let's say version 0.1 and generate. So now once the dataset is generated, we can export the dataset. So you can select the format around here. So again we will select yolov5 PyTorch format. I already told you this step of data annotation is optional. So whatever data we got from CVAT, the annotation step is also okay, but if you want to add more data, to more synthetic data to the dataset, then we have to go through this augmentation step. So let's go and continue the export yolov5 and then download zip. Okay, so in folder. Okay, so this is the zip file that we downloaded. Now it has train set with images. See, this image was not in the dataset, but it added some augmentation and created this data. So now we have this dataset in train, images and their labels in different folder, and for validation set. and together with that we also have a file called data.yaml. so this data.yaml defines where is the training images. So training images is in the folder train, in the train folder, and inside train, inside image folder, images, in same for the validation. And the number of classes we have is only one, that is only screwdriver. So that things are defined in YAML. So now we are ready to train our own custom dataset, but